Hello, AP Physics 1. It's Mr. Ng going over number 27 out of giancoli in chapter 7. This is about momentum. I really like this problem. It goes through a lot of little details about conservation of relative speeds, and it ends up talking about Newton's third law. Let's hop into it. A car A has a mass of 450 kilograms, while car B is 550. They have different passengers. If car A approaches at 4.5 meters per second and B is at 3.7, calculate their velocities after a collision. They do have a nifty little diagram here, but I like making my own where I set up P1 versus P2. This is momentum 1 versus momentum 2. And then we have A versus B. They're both going in the same direction. All right, A and B. All right, and there is a collision, and I like setting up my M, V, and P. M, V, and P. This is mass, velocity, and momentum. So the first mass is going to be 450 kilograms. Velocity here is going to be 4.50 meters per second. If you multiply those two, you'll get 2025 kilogram meters per second. This one is 550 kilograms with a velocity of 3.70 meters per second. You'll multiply those two values and you'll get 2035. So then our total momentum in the beginning is going to be, if you add those two together, it's like 4060 kilogram meters per second. Good. That means this thing, the total momentum here is going to be 4060 kilogram meters per second. Haha, makes things a lot easier. So to solve for this, we'll need to know a couple of things. Number one, let's just set up the conservation of momentum. That means MA times VA final plus MB times VB final is going to be this number, conservation of momentum, 4060 kilogram meters per second. And then we do know these values. Great, so we could plug those suckers in. 450 times VA final plus 550 times VB final is equal to 4060 kilogram meters per second. Fine. We need some extra info here, so we need to talk about the relative speeds. Relative speeds basically goes like this. The difference between VA initial minus VB initial is equal to the negative of VA final minus VB final, right? We do know VA initial and VB initial, so those values are 4.5 minus 3.7 is equal to, I like distributing the negative, so this becomes positive VBF minus VAF, right? I just trying to change the signs. If you do a little math here, this becomes 0.8 is equal to VBF minus VAF. That means we could do a little bit of moving around. VBF is equal to 0.8 plus VAF. And this is ready to be substituted in right there, which I'll need to do on the next slide. Okay, so in the last slide, we figured out two things. We figured out that VBF is equal to 0.8 plus VAF. That's the last thing we figured out. On top of that, we knew that 4060 is equal to 450 VAF plus 550 VBF, right? This is from the conservation of momentum. This is from relative speeds. So now all we got to do is put this sucker right into here. So that means 4060 is equal to 450 VAF plus 550, oops, this is 0, times 0.8 plus VAF. So now you could just have to do a little bit of math. I don't want to bore you with it, but if you do it all right, VAF is equal to 3.62 meters per second, right? And this is positive, meaning it's moving in the same direction, as you can see in this diagram here. That means VBF is basically equal to 0.8 plus VAF, right? That's what it was right here. Look over here. So that means VBF is going to be 4.42 meters per second. Ta-da! So VAF is going to be equal to 3.62. VBF is going to equal to 4.42 meters per second. So we're not done yet. Part B, they want the change of momentum of each. And that's pretty darn easy. J of A is equal to mass times V final minus V initial. And we have the V final and V initial right here. So J A is going to equal to, the mass is 450 kilograms times 3.62 minus 4.50. So J of A, the impulse of A, is going to equal to negative 396 Newton seconds. Okay, and notice the negative from over here. That means even though it didn't change direction, it did not change direction, but it slowed down a little, so it lost momentum, right? It slowed down. So here, JB is going to be equal to mass times VF minus V initial. So that is equal to 550 times, let's see, V final is 442 minus 3.7, 3.70. And then if you do that, it's also 396 newtons seconds. What? Right? But this time it's not negative, it's positive. So think about Newton's third law. All of that reaction, every reaction has an equal and opposite. Every reaction has an equal and opposite reaction. There you go. There you go. Look, positive number, negative number of the same magnitude. Thanks a lot for watching. I know this was a long one, so thank you. Bye-bye.